Alright class, so section 3.2 is all about the graphs of functions. This is where we're going to start working on our skills to become really good at visualizing what a graph looks like when we see its equation. Just a heads up, I'm recording at home, so you're probably going to hear my cat at some point. She talks more than I do. So what's some information that we can obtain from an equation or a graph? So there's a lot of different information we can obtain. First off, we can tell if it's a function, right? If it passes the vertical line test. We can find our intercepts, not just our x-intercepts, but also our y-intercepts. We can determine if it has symmetry. Remember, there are 3 different types of symmetry. There's symmetry around the x-axis, y-axis, and origin. We also want to determine its domain. Remember, that's all possible x values our graph could take on. And we also want to determine its range. That's all possible y values. What's also great is we can find a specific y value, f of x value, given our x. So let's take a look at this equation right here. I've got x squared plus 2 over x plus 4. I want to know, is the point 1, 3/5 on the graph of f? So how could we do that? Well, we could substitute in for 1 in order to determine if this point is on our graph. So if I have f of 1, that gives me 1 squared plus 2 over 1 plus 4, which is going to give us 3 over 5. So I have that my y value is going to be 3/5. So this is true. Yes. This point is on our graph. Next, I want to know if x is 0, what's f of x? So I could take f of 0, and that would equal 0 squared plus 2 over 0 plus 4, which is 2/4, which is a half. So that means that the point when x is 0, y is a half, is on our graph. Next, it's asking me what is our domain. So our domain is going to be all possible x values that this graph can take on. So if I have x plus 4 as my denominator, and I know I can't divide by 0, if I set that equal to 0, I'd see x is -4 is the only value not in my domain. Next, it's asking us to find our x-intercepts. So remember that our x-intercepts are when y equals 0. So if I set my function equal to 0, let's do this in green. This is number 4 up here. So 0 equals x squared plus 2 over x plus 4. I could multiply both sides by x plus 4. That gives me 0 equals x squared plus 2, right? If I subtract 2 from both sides, I get -2 because x squared. And because I can't solve for x in this case, this means there's no x-intercepts. So there are none. The y-intercepts are when x equals 0. And luckily for us, we already solved that. We found that our y-intercept when x is 0, y is 1/2. Next, I'm going to need to know my range. It could be really helpful to use a graphing tool in order to determine our range, right? But I know that 0 is the smallest number I can plug in, and y is going to be the smallest. 0 isn't the smallest number I can plug in, but 1/2 is going to be the smallest number I'm going to get, right? My graph doesn't get any lower than that. So my range goes from 1/2 to infinity. So let's look at this graph and answer the following questions. So what is f of 5? So if x is 5, f is 4. When x is 5, f is 4. What's f of -5? Okay, when f is -5, y is 1. State the x and y intercepts. So why don't we just go ahead and label them. My x-intercepts are here when x is 3, and also here when x is -1. So I have I have 3 x-intercepts. My x-intercepts, remember, that's where y equals 0. I also have a y-intercept. That's right here when x is 0. I have my y-intercepts. So here's one of our y-intercepts. What is my domain and my range? So my domain is going to be all possible x values that our graph can take on. So my domain, if I look at this graph, goes from -5 all the way to 7, and that's it. So I'm going to use square brackets because my endpoints are included. For our range, I want to look for the smallest value and the largest value this graph takes on. So the smallest y value I have is -2, and the largest I have is 4. So the range goes from -2 to 4. Cool. Next, how often would the line y equals 2 intersect our graph? So let's go ahead and graph this. Y equals 2, remember that would be a horizontal line. Here's where y equals 2, so I'm going to go ahead and draw it. So it looks like y equals 2 would intersect my graph 1, 2, 3, 4 times. Next, it's asking how often does the graph, we'll use a big thing, x equal 5 intersect the graph. Remember, this is a vertical line. So I'm going to go ahead and plot this, and you can see that it only intersects my graph once. Next, I'm wondering, for what value of x is y 3? So let's go to where y is 3. That's here. So when x is -3, y is 3. So that was some examples of information we can glean from a graph. In this next section, we're going to start taking a look at what these graphs look like, what different equations graphs look like.